they have included. I will tell you that, right? So that's pretty unfortunate because we clearly discussed what should be tested, and now they are saying they have added it, but not in big amounts. Right, so we need to go through this. Right. Okay. So this chapter is about programming languages. Programming languages are the softwares that we use to write other programs, such as Python. Right. Can you hear me?
Yes, sir.
Yeah. Back then they used programming languages, a set of programming languages called low-level programming languages. Now, these low-level programming languages are closer to the machine readable format, which means machine or the computers, they understand only ones and zeros like this. So this ones and zeros are called machine code or machine language or the binary language. And every instruction has to be converted into every instruction and every data has to be converted into machine code for the computer to execute. That's what actually happened in the CPU. Remember the fetch, decode, execute cycle? Instructions were converted into machine code. Machine code program would look like something like this, like ones and zeros. And later, people saw that this is really difficult to write programs using ones and zeros, machine code. So what they did was they came up with programming languages that are closer to humans. Little by little, they were getting closer to the humans. Human readable format, human understandable format. As a result, they came up with a low-level programming language called assembly language. Assembly language. I think you have heard about this, right? And I think you have done this in lower classes. Nothing much. They came up with assembly language, which used some mnemonics, a coding system, right? And the problem with this language was, uh, I mean, it was easier than definitely using ones and zeros, but it was challenging because you had to remember the exact code to execute, to write the programming code. So there was a code set. They were mnemonics like short codes. You had to remember these codes when you were writing programs using assembly language. Now, if it is not written in machine language, ultimately the programming language has to be, that program code has to be converted into ones and zeros or the machine code. This is done by a system software called translator. Translator. It's something like translating one language to another. When one is speaking French, the other one is speaking Chinese. We need to translate the two languages. So the translator comes in and converts the program code into the machine code. The program code can also be called the source code, is converted into the machine code so that the CPU can run. So if the program was written using assembly language, the translator used was called assembler, assembler, right? But still, assembly language was called low-level programming language. Why? Because still the programming language was not so user-friendly for the humans because they had to put some effort to remember these codes. Right. Um, Something like this, you can see. Assembly language is a bit easier to work with than machine code because each instruction is written as a short, memorable keyword called mnemonic. For example, instruction for the CPU to add numbers together might be uh, a bit stream like this in machine code, but add in assembly language, right? So add is fine, you can remember, but look at this LDR, MQV, CMP, MOVGT, and the addresses, the memory addresses, uh, was not at all easy, right? So the assembly language that was written like this had to be converted into machine code like ones and zeros using an assembler, which is a translator, right? LDR load register, STR store, CMP compare two values R3 and RO. Still not user friendly. So it was called low level language, which meant that it was not easy for the human, but still it's closer to the hardware. But there was some kind of improvement. Right. Writing programs in assembly language is challenging for three reasons. A very limited range of instructions is available. There was a set of instructions already defined. So it couldn't be used for high-end tasks. You have to manage all your data. There are no strings, integers, real numbers, just binary. So you have to decide how to represent your data. You also have to decide and manage where it is stored in the memory. So you should have an idea about the memory locations. And you should have an idea about how the data are loaded into these registers. And so you have to kind of have an idea about how the hardware works there when you're writing the code. And there were no data types. Debugging is very difficult when the assembled program runs. Any bugs usually just make the machine crash and you have to reboot and try again because it was running on the hardware level. It could easily crash because there was no program to look into this. So you were directly, I mean, you were directly or mostly you were handling the hardware. So the chances of getting crashed and getting errors was more was high. So what were the problems with the assembly? The mnemonics you had to remember. It was not easy. Then you had to have an idea about how the hardware works, how the memory works, and memory locations are used. And there were no data types, so they were all binary. And then debugging was not easy. It led to crashes often, so you had to reboot the system. Nowadays, almost no programs are written in assembly language. The exceptions are some hardware drivers and programs are designed to run on embedded systems that you learned about earlier in the chapter. So except for like microcontrollers, then driver software and instructions written into embedded systems like this firmware are written in assembly language, but not the applications that we use. So they all are written using the modern applications are written using high-level programming languages. Now, why are they called high-level programming languages? Because they use a language, they use a command set, right, which would be as close as possible to human natural language. When you want to print, we just type print. When you want to input something, we just type input. So it's really close and it's easy to remember, and you don't need to buy hard. It is much more common to write software in high-level programming languages such as Python, C Sharp, Java, Visual Basic. For these programs to run on CPU, the source code has to be translated into machine code. Yeah, again, anything not written in ones and zeros will have to be translated. So do these high-level languages. But the translators that we use here are different. It's not assembler. It's going to be either a compiler or an interpreter. I think these two names are not new to you. You have heard these terms in lower grades. Compilers and interpreters. We'll look at the differences in a moment. Okay. This can be done all at once and finish machine code program saved on run later at a line at a time. We'll talk about the differences. So all modern day programming languages are high level languages. They are very much closer to the human natural language. And it's easy to code and it's easy to manage and easy to debug. Data types are there, right? And you don't have to worry about how the hardware works, how the memory works. They provide a lot of abstraction. You don't need to think about how underlying codes run. You just need to make use of these codes, functions, and procedures. For example, when you use input function in Python, we don't need to worry how input function works. We need the syntax, but we don't need to worry how it actually happens in the background. That's abstraction. So there are two types of translators used on high-level languages. What are they? Compilers and interpreters. What are they, Rushda? What are the translators used in high-level languages?
Compilers and interpreters.
Compilers and interpreters. Good. What are they, Naila?
Compilers and interpreters.
Compilers and interpreters. Good. A translator that translates the whole program. Now listen to this very carefully. You get questions often asking you to compare these two. A translator that translates the whole program in one go, at once. It translates the program code into the machine code. Now remember, this machine code is also called object code. The program code is also called the source code. So it's source code to object code or program code to machine code, whatever. What does it do? The compiler translates the code at one go, all at once. Whereas the interpreter translates line at a time. Line means a program code line at a time. That's the main difference, right? So where does Python fits in? Is it using a compiler or an interpreter? What's your answer? Is Python using a compiler or an interpreter?
The interpreter.
Interpreter, good. Right. How do you know? How do you know?
Because it gives us the specific line where there's an error.
I can't hear you, Atma. Speak louder.
So because it gives us the specific line where there's an error.
Okay, that's one method. Yes, it shows where the error is in the line. The main thing is in an interpreted language, a program, there's no button called or there's no option called compile. Right? In all the languages that use a compiler, there'll be a button or an option called compile. Right? You will have compile as well as run. So what you do is you first compile and then you run. In languages where you have interpreters, there's only run. In Python also, you have only run. There's no compile. Okay. So a compiler converts high-level language to machine code and saves the output as a machine code program, which is called the object code. So it creates a separate executable file after compiling. This executable file or the object code can be run any number of times, right? Without the need of the program code. You can transfer this exe file to another machine and run. Usually an exe file, short for executable, because the machine code can be executed or run. But interpreted language, you can't do like that because it runs then and there, and it translates line by line into machine code. Translates the source code one line at a time and then runs. There is no object code on your original source code, only your original source code. So when it runs, if there's an error in a particular line, as Atma said, it will stop running. That's why you saw the Python was stopping. When you were running it, it stopped, right? If you were using a compiled language, it won't let you run until you debug completely. If there are errors, it will list down all the errors once you compile, like in Java, C#, and you are going to debug each and every line separately. Obviously, it will help you to debug. It will help you to find out where the bug is. And then you have to debug and you have to make it error free. And then only it will let you run. Whereas interpreter will straight away start running. When there's an error, it will stop. Right. Okay, so here are the differences. So if you are going to run an interpreted language program, you need to have that interpreter in that particular machine that you want to run. Every computer that will run your program needs the interpreter software installed. So if you move your Python code to a machine where Python interpreter is not there, it will not run because it's an interpreted language. Whereas compiler, the output from a compiler will run on its own on any similar computer. If you have a similar computer with similar, setup, hardware and software, it will run because it's an exe file, executable file. Interpreters find errors when they happen, and can often tell you what has gone wrong. The compiler cannot produce any object code unless the whole program is correct. They tend to report lots of errors, making it harder to debug the program. So why is it easy to debug the interpreter? Because the moment it finds the error, as Atma said, it will stop. So now you know exactly where the error is. But compile is not like that. When you compile, it will list down so many errors. right? And you will get frustrated seeing these errors. It will show like your program has 20 errors and these are the errors. So one by one, you have to locate them and debug and recompile until there are no more errors. Then only you can run. So debugging a compiled language can be a nightmare. Right? Programs tend to run slower using an interpreter because the interpreter has to translate while the program is running. Right? Because it's running, it's using resources, and you're checking the line by line, we are checking line by line for errors. They tend to run slower than the compiled programming languages. It can be easy to protect your code from being altered or copied if it has been compiled because only give people the object code, which is hard to understand. So since the compiled language is creating an object code, which is an exe, it's hard to read that file. It's like hard coded. You won't be seeing the code that was used to develop it, and it can be transferred among similar computers easily. So in that case, compile is better and it runs faster because it has already been compiled into machine language. So just need to be executed. Whereas interpreter can run slow, but it's easy to debug because we know exactly where the program halted. Okay. Now you have seen like people call translators, right? Where when a politician goes and gives a speech in a different area, there will be a translator usually. Have you seen they translate in two ways? One way of translating is after every line or sentence that the guy says, the translator will convert. So that's like an interpreter. He translates every line, line after line. So mostly we see people like that, interpreters. If the translator person, right, starts translating after that guy finishes the speech, that's like a compiler. Okay, so relate these to real world examples, then it's easy to remember, right? Okay, so that's interpreter and compiler. That's it. So very short this thing. Okay, that's the end of the chapter. Uh, Let me jump to that range check example, which we couldn't do. That was here. We did the lookup check. We need to do the len check, right? Okay. Len check and the types of errors, and then we are done with that as well, right? Okay, so just stay awake for 10 minutes, right? Len check. It is sometimes necessary to check that the length of a value entered falls within the specified range. For example, all UK postcodes are between 6 and 8 characters long. So validation could be used to check that the length of the postcode entered is within this range. Okay, like how? Receive postcode from string keyboard. Set length to length of the postcode. If length is greater than or equal to 6 and length is less than or equal to 8, send valid to display, else send valid invalid to display. Okay, simple. Let's code this. Range check. Receive postcode from string keyboard. First watch, okay? Watch. So postcode equals input, no int because it's a string. Enter your postcode. Okay. Get the length of the postcode. Set length, no? Set length. Length equals len. The Python command for length is len. Len of postcode. Now you need to check the length. How to check? If length is greater than or equal to 6, and many students they forget to use the variable again. Don't forget that. You have to put like this. Many students what they do is they put like this, less than or equal to. That's wrong. Right? You can't say if length is greater than or equal to 6 and less than or equal to 8. It should be length less than or equal to 8. Okay. Then if that is true, print valid, else print invalid. Simple. Run it. Okay, run it. Postcode that's 6 characters. Valid. Uh, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 characters. Valid. Let's put this is how we test it. Let's put an invalid postcode. Invalid. Let's try more than 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Invalid. Understood? Did you understand? Can I see a thumbs up? Naila?
Yes, sir.
Okay, great. I'll give you 2 minutes. Can you write this code and check very quickly? Now remember when you're testing a range check, when you're testing a range check, you have to test it in some specific ways. Like what? You have to try a valid number. That is the range in between the upper boundary and the lower boundary. And then you have to test the boundaries. Oh, someone has already typed. Then you have to test the boundaries. What are the boundaries? 6 and 8. Then you have to test invalid numbers. What are the invalid numbers? Less than 6 and greater than 6. Okay, can I see the others also? Atma has shared the screenshot. Who posted just now?
Sir, Arham.
Arham, right? Okay, Rushda did, Naila shared, Arham shared, Fatma. Can I see the others also quickly? Who shared now? Whose number? That's Tilakam, right? Okay, right. So others who didn't do quickly do it and share it. Okay, I'm moving to the last one in this testing validation rules. Okay, so this is pretty easy. Text file handling we do in grade 11. Okay, right. So when you're testing, you have different types of data to be added. It is important to test your validation rules to ensure that they work as expected. Now, you already know that validation doesn't check for accuracy, it checks for acceptability. So, when you are entering data, you have to check with normal data, right? What is this normal data? Data that is limits, within the limits, which is normally accepted. Normally accepted within the limits of what is accepted. For example, a password with 7 characters fulfills the validation rule that states that the password must be 6 and 8 characters in length. So this is what we normally test. We test for normal data. But I mean test for normal data in the sense like if you are users, if you are normal users, we enter normal data. But quality testers, what they do is they go to the extent of checking boundary as well. So if there's a range check, they will check the boundaries as well, apart from normal data. This is data that at the outer limits of what we should be accepted. For example, if a validation rule specifies that the range of acceptable value is greater than 75 and less than 100 is at the upper limit and 75 is at the lower limit. Those are the boundaries. So a software tester would be testing the boundary data as well. We as a normal user will be entering the accepted data. Okay. And finally, erroneous data or invalid data that should not be accepted by the program. A value 0 should not be accepted by either of the validation given rule given above. Here, it should be greater than 75 and less than 100. So the 0 should not be accepted. In this one, password should be between 6 and 8 characters. So a 0 length password is not accepted. Okay. Arham, tell me what are the types of data that we should be using to test validation rules? What are the types of data that we should be entering to test validation rules? Normal data,
So is it normal data? Yeah.
boundary data, and
And boundary data? Yeah.
yeah, normal data,
Oh, error.
erroneous data, or invalid data, right? Okay.
Okay.
Naila, tell me what is boundary data? Boundary data. What is boundary data? Naila?
So it accepts only
It checks